Okay, before we start, I would like to do a short introduction. Today with me is Miriam Brenner from the B39 Academy. She is in the chat, and she will support me for technical reasons, and also if you have questions during the session, neither to technical stuff or questions for the webinar, for the session, please feel free to write these questions in this chat. My name is Patrick Schick. I'm Product Marketing Manager at IDS, and I guide you through this session today. Some housekeeping information. As told before, Miriam will review your questions, and we will try to answer those questions in defined slots. If we are not able to answer this question today, we will send you a link, a download link for the slides. We will also send you a Q&A document where we try to answer all the questions. So also you will get the slides later on via a download link, and then you have everything together from this session. We start now. During the session, I will switch off my video so that you can fully concentrate onto the slides and on the live demos we will do during this session. Let's start. Today we have the IDS NXT Ocean. Basic IDS NXT Ocean is our all-in-one inference camera solution. It is a complete solution for AI-based image processing. It brings you as a user in a situation that you can solve issues where you're not able to solve with rule-based image processing, or which is hard to solve with rule-based image processing with deep learning without having deeper knowledge of deep learning. So you're the expert in an application, and we provide you all the tools to solve your issues with deep learning without knowing the tools itself. So let's do an example. You have an issue that you're packaging foam kisses in this case, and you would like to know, okay, are all foam kisses present? Are they absent, or are some of them damaged? And as you can see in the images, there are different flavors of foam kisses also, even if it is the same type of the shape may a little bit differ, and they are not as accurate as a mechanical part, for example. Also, if there is a damage on the foam kiss, it could be totally different. They may be only split a little bit of chocolate away, or they may cut in half. That totally depends. And you, as a producer of foam kisses, you are expert in. So you know which foam kisses are good and which are bad, which shouldn't be delivered. And now it would be pretty great if we could use your knowledge, it is in your brain, and duplicate this and spread this over the field to your machines, to every vision system into your machines. This is feasible and this is possible with the IDS NXT Ocean service. So let's imagine you have the knowledge, and then we provide this into a training system. So we train a brain which we then easily can copy and deliver into your factory floor, into your machines. Your knowledge is now copied via a deep learning training, and we can provide this now and copy this available networks to a lot of different systems and can do machine vision there. The only thing you need, therefore, is IDS NXT Ocean. And that's our major topic today. So we will have a look what is inside of IDS NXT Oceans, which kind of components these are. And then we want to see how we grab, label, train networks, how we let it run, and we will stop with a short outlook. Okay, what is in the box? Therefore, we have to open the box and have a closer look into it. This box is not only a virtual box. We sell a IDS NXT Ocean design-in kit, so where all of these elements are included. So we have a complete running camera, we have with cables and all necessary things included. So you order it and you have then a complete ready to run set. So first of all, we have an IDS NXT hardware inside of it. We deliver the box with an IDS NXT Rio, which is not directly in the box but can be downloaded via our website. Is software to interact with the cameras. Today in this session, we majorly will focus on IDS NXT Cockpit and IDS NXT Crawler. And last but not least, there is a voucher included to access the IDS NXT Lighthouse service, our IDS training service for neural networks. And now we will have a closer look to the single components. And we'll start with the camera. The IDS NXT camera family consists at the moment of 2 versions. We have the IDS NXT Rio and the Rome. And for those of you who are familiar with IDS products, may see that the Rio is looking like an SE camera, and the Rome is looking like a FA, our factory automation family. This is not by accident. This has a sense behind, because the IDS NXT Rio is similar to the SE, for example, available as board level versions. We offer in both systems a wide range of sensors, and you can expect from hardware side at least similar features like we have in the IDS UI cameras. The Rome comes additionally with IP65, 67 waterproof directly out of the box, so that you even can let run or use this camera in outside applications or in applications where you have to deal with liquid. But these are not SE and FA cameras, and so they have to be more. One major thing we run on every camera web server is running. This web server enables you to access the camera via web browser, for example, to easily see status information, to see is the camera working, how is the inference status, and so on and so on. And this is completely device independent. You can do this from your mobile phone, from your host PC, whatever device can show a web browser. As next, we offer vision apps on the system, like the apps on your smartphones. You can upload new functionality to the IDS NXT cameras. I have to say that for the moment, this is only possible for IDS. So we can deliver new apps, but as we are in the beginning of a development here, you can expect that in the future we will also offer the possibility that you as a user can upload your own apps. And last but not least, we have a new communication interface here. We're using the REST interface. And there I will dig a little bit deeper into it. So REST is a stateless transfer protocol. It's a web service, and it's an open it's an open protocol for machine-to-machine communication that allows easy networking between systems. REST is a protocol which comes out of the IIoT world, of the Industrial Internet of Things world. And this is also our view we have on IDS NXT. We see NXT majorly as a device which autonomously operates. So therefore, we have also to provide a generic communication interface and reduce the overhead on a PC. So especially for the API, the interface PC like GennyCam or the IDS software suite would be such a overhead on a PC. We get rid of this, and we are allowed to configure and interact with the camera either over REST or over iOS and RS-232. Who'd like to get more information about how the REST interface is used with IDS NXT, we have here a link to a tech tip, especially for this topic. And in June, we will offer also a next webinar where we show how to integrate an IDS NXT camera into a factory automation environment with REST. So if you're more interested in this topic, join these webinars and read this tech tip. But at least to summarize this, we see IDS NXT as an IIoT device. Therefore, we need communication interfaces which are commonly used in IIoT. And in this case, one of the majorly used interfaces there are REST. But that's not all. There is one thing more which, let's say, makes the major difference between the NXT and the UI family. The IDS NXT cameras have the deep ocean core included. This is the real highlight of this camera because the deep ocean core is a hardware accelerator for the FPGA. It accelerates the runtime of neural networks. So we optimize neural networks, and we are able to let neural networks run on an embedded device or an edge device, which you normally would need the power of an host PC for. So we accelerate this on hardware. We can parallelize the CNN operations. We make a much more efficient memory management, and we optimize the neural networks, especially for our FPGA. With this, a nice feature comes aside, because as we control the software and the hardware, we are able not only to predict the inference time, we can ensure the maximum inference time. So we can ensure, and you as a user can choose, we see this later in Lighthouse, can choose how long the inference shall take. As we have both under control, the hardware and the software, we can guarantee this in this case. And this is a unique point here, because the most other systems cannot ensure this combination because they are not aware of the hardware they are using. So if you have a high power CPU or GPU, it would run faster. If you have a low power system, it would take longer. Here we have the combination of both, and so we can ensure the maximum inference time. That's all for the moment for the camera. If you'd like to get more into details, which sensors are available and so on, please join our website. We will now change our focus to the software part and have a look on the software which gets delivered with IDS NXT, or which you have to use. Two major parts, which are also topic of the talk today. One is the IDS NXT cockpit. For those of you who know the IDS cockpit from the UI cameras, we offer here a complete graphical user interface to interact with the camera, to parameterize the camera, and also to validate the results, in this case of the inference of the camera. So everything you can set up also via an API are able to set up over the camera, over the graphical user interface. Another tool is IDS NXT Crawler. With IDS NXT Crawler, we give you an easy kind of way on hand that you can store images to train neural networks. Crawler has two parts. One is running on the edge device, on the IDS NXT camera. Another one is running on the host, which receives and stores images. And I don't want to dig deeper into slide details. Let's go live, and I will show you those two products, and we will start acquiring images to be able to train a network. I have to switch monitor just a second. Okay, we are now here in the cockpit, the IDS NXT cockpit. We just have started it. When you open it up, the IDS NXT cameras are visible here with their IP address. You can give them unique names. With a double click on it, you can log in into the cameras. As you see here, we have a roles for the camera. So you could either be there as a user who is then able to monitor applications. You could be an administrator who can set up the complete system and also applications. And you could be a service person, which then is more capable of integrating NXT in an automation environment. So let's log in. Next thing we start then is the dashboard. We get information about our NXT. We can see the status, in which mode is running, temperature disclosure, and so on. A typical status site. Similarly, you can also see via the web browser. The next interesting tab here is the configuration tab. And now we see a live image. We give it a try. Yeah. In Germany, it's now 5 before 4 o'clock. And here you can set up the camera itself. We have the possibility to change exposure to the well is need. We have gain. We can do auto white balance over the gains. We offer histograms and so on. Things you may know from classical machine vision cameras. We can set up triggers, either let the camera run in free run, which is good when you're just setting up a system and play around, but still there are software and hardware triggers available. We will see the usage of them later. You can do different settings, or less general settings. We can exchange names, give it time zones, and so on. Similar to network setup users and interfaces, but more of interest is now here the app manager. There are some pre-installed apps available. We have two for the gateways, which enables us to communicate outside with machines in this case. This is a topic we will handle in the next webinar. I've just pre-announced. This is not topic of this webinar here. And we have a CNN manager, which let us run neural networks and see the inference time. And we have crawler. Crawler is, as I told before, the tool to acquire images, to store images on the PC, to acquire training images. And we will let crawler run. You see now here we have another app available, the crawler app. And in crawler, we have the possibility to choose a region of interest where our item will be later on. And still we can switch to the camera tab, and we can set up, for example, the right exposure time. And as we would like to classify foam kisses, let's set up that this foam kiss gets detected. Let's reduce a bit. Let's set our ROI perfectly. Back to the app. So now we have the ability to switch on save, and then automatically images will be saved. We can set up a first class, which we will do now because this is not a defect, this is a present. And here we have an URL. This URL is the host component of crawler. The host component of crawler also sets up, okay, on which interface he is listening. We give it a path where images shall be stored. And then we let crawler run. And now you see here an URL and a copy button. And then you easily can copy the URL and writes this here into this URL path. Then our embedded device component knows where to store the images. Before I start saving the images, I switch shortly to camera and switch to software trigger, because if I would let it in free run, it would acquire 16 frames per second from the same foam kiss. That's not what we want to have for the moment. So I'm on software trigger now. I switch save on. And as you can see, the image transmitted number increases every time I acquire an image. So now I have an image of the present, which also is often good to know is to have an image of the background. And for sure, as we want to be able to distinguish between good and bad foam kisses, we also have a defect class. I have to destroy one. Tasting nice. And acquire an image. And now we transmitted an image of an defect foam kiss. If we look on the folder structure now, here we have just acquired a defect one. This is our time at the moment, yeah. And we also acquired the two present one and one background. So that's the images we have now acquired with IDS NXT crawler. This was an example here. You can imagine if you integrate, for example, the IDS NXT camera into your application as a normal machine vision camera connected to the hardware trigger, you could acquire in a short time a lot of images of your products, of your items under investigation. So switch off saving here, and I switch back to the presentation. Had a look on the NXT system, how it works, and now we change our focus to the software, to the cloud service part, and I would like to introduce IDS NXT Lighthouse. IDS NXT Lighthouse bundles all the specialist know-how which is necessary to train a neural network. So you're the expert of your application, in our example of the foam kisses, and we are offering you a system which is expert, which is specialist of deep learning of neural networks. So you have to bring your knowledge and your images to NXT Lighthouse. We train networks, and you receive a trained network, which then again can deploy on the NXT cameras. And you do not have to take care about deep learning knowledge. So we have the knowledge integrated for you in Lighthouse. And you also do not have to care about investments in hardware, because the hardware is also included in the cloud service in Lighthouse. So with Lighthouse, we will make two things possible. We will simplify your workflow. You only have to grab and label images, upload them, set two properties, and then the network will be able to train. And this brings me to the second point. So we would like to offer you a system, or we offer you a system which is immediately ready to use. You have nearly no pre-knowledge. You don't have to train your people for this system. Upload images, start a training, and then download a trained network and let it run on NXT. This workflow we will see now in the next session. So we will switch back to a live demo. And now we switch to Lighthouse. This is a start screen of our Lighthouse. You have to log in with your IDS credentials into the system. And now we're online. We distinguish majorly in Lighthouse in projects and data sets. So, and in projects, you can handle all your, as told, different projects. In our case, we have the foam kiss project. So you have a title, a description, can set up thumbnails, and you can set up an email address where you then get notifications sent if something happens on your project. In our case, for example, if a training is done, you get mail, so you don't have to wait for the training. You get informed. To the project, you can assign data and then start training. First, let's jump to the data. We can either create a new data set here when we go to the data tab, or we can jump to the data sets and just prepare different data sets. In our case, again, we have the foam kisses. We see all the images. We have taken for. And one of the major parts which is interesting is on the one hand here we have the statistics. So we see how many images we have and how is the different labels, how many we have per label. There is at least one part is that we have equality, nearly equality between the different labels is one of the major reasonable parts when you start training neural networks. It's not always the count which matters, because you're able to start with a small data set to check if the problem you have is solvable with deep learning. So it would be even good enough to have up to 50 images per label to give it a try if it really works or not. But it has to be then again equal between all the classes. For sure, if you want to have a more accurate values, you have to have more images. We can filter those. So about the absent images with absent label, different defect labels, and so on. And we can add images here. We'll do this now because we acquired new images. So this defect is a new one. So we will upload this image and give it directly the label defect and upload. Now we're up to 190. We also acquired a present label. We only use one of it, give it present, and upload it. So that's all you have to do if you had acquired image and would like to start training your network. For sure, you can upload complete contents of folders, not only one, as I've shown here. And to give a little bit of structure and organization, if you organize this in folders, it's easy to upload a complete folder, label this folder, and makes your life easier inside of Lighthouse. In the future, we will also enable a direct way that with IDS NXT crawler, for example, can directly upload images to Lighthouse. But this is something which will happen in the future. We don't have this at the moment. And so our system is set up that we also, on one hand, can support easily people who acquire new images with crawler to give them a structure with the labels as folder names. On the other hand, we see from prior knowledge that most people who are working with deep learning, who are collecting images, normally use a folder as a kind of structure element, as a kind of label element. And inside a folder are all foam kisses, in our case, which are defect, in another folder, which are absent. So we also would like to support, or we support with Lighthouse, this behavior, people who have still images available. So now we have the images there. In the labels, we can see the different labels which are available, how many images. Again, inside of the label, we can change names, we can delete labels or add new labels. But what we want to do now is to assign this FoamKiss dataset to our FoamKiss project, which is still done here. And then we would like to start a training. And therefore, you don't really have to know anything about how a deep learning neural network has to be trained. And if you have to set up something, we also give you all the time some hints for this. So normally, it is good to enlarge the data set by manipulating the images you have. This is done automatically and randomly with an internal algorithm. You don't have to take care of it, but so we show, or we have a pre-setup, therefore, which we see would be the most perfect way. But if you would like to adjust here a little bit, feel free to do. You can enable, disable, and also define the value, how heavily something shall be transformed. And then, which is, as told before, one of the unique points, you can really define a time requirement for your neural network, how long the inference shall run on the camera. You're able between 50 milliseconds and 120 milliseconds. For sure, networks will take a longer time, can have a higher accuracy, I have to say, because depending on the data set, often also a 15 millisecond network is good enough, or doesn't show big difference to 120 millisecond set. But it depends on your issue you have to solve, and this depends on the data you provide. And then we start a neural training. I will go to 25 milliseconds and click on Train Neural Network. That's all. Now it's get queued, and as soon as hardware resource is available and everything is prepared, because we have now to upload the images to servers and so on, the training will start. You then have the possibility either to check your configuration, which modifying you're using, which cycle time is added, and you get a history of your training sequences of the accuracy. I will show this to you in a pre-trained network. Here we have statistics available, and we see that we reach up to 100% accuracy with this network. So also here, we internally split the data set into different sets. There are a lot of images we use for training, images we use for verification of the training. And that's nothing you have to take care of. We do this in IDS NXT Lighthouse for you. So there is no special knowledge you need. And after the training is done, just can click on the download button and the neural networks gets downloaded. Now the network is available, and on IDS NXT, I now disable the crawler because we have acquired the images. For sure, the applications in this case can run in parallel, but I don't need crawler anymore. I switch it off. I go to the CNN manager. I start the CNN manager. We have the same possibility here. We can set different arrow eyes. And also the switch between camera and app. And what we see is that nothing happens because I'm still on software trigger. So I switch to free run. It starts, and it is one with a defect. Even we don't have trained this defect because this is another network now. Ours is still under training, and this will take some time. But now let's upload a new CNN. In complete running system, you can press this upload new CNN button. Then always when Zoom is open, it takes a while. And we're then able to upload a new CNN and can directly exchange the CNN on a running system here in the CNN manager. So we go on downloads, took this brand new neural network, file is uploaded. We switch to the newest one, and it's still a defect. Now it's absent, nothing is there, and we have a present foam kiss there. So the only thing we have done now is grab images with crawler, we upload it to Lighthouse, we label them, we train the neural network, and now we have a complete application running with deep learning without prior knowledge of deep learning and neural networks. And let's see if it works live. Perfect. Again, some foam kiss on the fingers. So now we have a complete round trip, and I will switch back to my presentation. So to bring it together, we have a workflow. We acquired images with the IDS NXT camera, with our IDS NXT software. We upload this to IDS NXT Lighthouse. We trained the neural network there, and then we get back and let this neural network run on NXT. For those of you which are much more familiar with neural networks, there is not only the Lighthouse way, we offer also an expert tool for those people which has pre-trained network or still investigated in networks. When they are based on the Keras framework, we offer an expert tool that's named IDS NXT Ferry. This tool enables you to upload your Keras-based networks also to IDS NXT. If you would like to try IDS NXT Ferry, please contact us, and then we make this tool able for you, for your usage. Hopefully I could get the question mark away during the last session, and I could give you an insight in IDS NXT Ocean, our all-in-one solutions to solve applications with deep learning without the need to understand deep learning or AI. If you would like to know more about deep learning and AI, I would refer you to a webinar in June. So have a look on our website. This is just on the preparation where we will have a look behind the scenes of deep learning and behind the scenes of Lighthouse, where we go deeper into the topic how Lighthouse is working and what is all necessary to train the networks. I would also give you a short overview of applications which are still solved with. We have a quality inspection, for example, if we have to verify welding points, welding spots, if they're good or bad welding spots. It's used in fruit sorting, or we have a growth state monitoring of grasses in this case, so that we get informed every time a grass reaches a new state or even can be harvested. Then when we look to environmental monitoring, in this case a parking space, it could feel a totally new webinar with topic why this application has to be solved with deep learning, but believe me, we see that rule-based approaches just fails because we have an unstable environment here, and we have much more robust results when we use deep learning. And last but not least, a topic we see more and more at the moment, especially in the medical area, up from classification of viruses or bacterial cultures, up to classification of X-ray images and so on. So a lot of different applications. I would like to tick the boxes here. So we had an unboxing of IDS NXT Ocean, what's all included also in the designing kit, which you could directly buy from us. How you grab images with IDS NXT, you label and train a network with and let them run on an IDS NXT to do their job. Before we come to the question and answer session, I would also give you a short outlook of the upcoming release, which we will have. This year we have release 1.1, and on the camera side, we will introduce a new interface. We will introduce OPC UA as an industrial protocol. We will enable, as I told before, that you as a customer are able to develop vision apps, and we will offer not only classification on an image, we will offer multi-AOI classification so that you could define inside of an image different regions to classify. On the Lighthouse side, we will offer tools to export, to import networks. We will offer a kind of versioning so that you have an overview and versioned networks. And one of the major investigations will be that we offer object detection. So as a new deep learning tool, not only classification will be there, we also offer object detection, and we extend our language package to French and Japanese. So this was a short outlook of what you can expect this year. Now it's your part. Please ask questions. Miriam collects them, and then we try to answer those questions right here. I will use the time and eat one of the foam kisses. Okay, I see there are just some questions are coming in, and we will answer them. So we have the first question here: how long does it take to do the training? This totally depends on the topic, how many images we have, how many classes, so how many labels are there. So that's hard to say upfront, but what we can say, and therefore I will shortly switch to Lighthouse again. I give you a view on Lighthouse here. You see the training we just started during the session. We have round about 550 images inside of it. We trained 60 epochs, and it's done in, we started 4:15, so at least maximum 15 minutes. But as told, it depends totally on your amount of images. I have to go back to the questions. Sorry, just a moment. The next question was if you're able to store videos. So this is not feasible at the moment to store videos with IDS NXT itself, because at the moment we have an inference camera, inference for still images, not moving videos, which may be also a feature which comes up in the future for sure, but is for still images. So we don't offer this feature. But when it comes to custom development, you would be able to develop something by yourself. Next question: how many images are required to train a neural network? First of all, it is you have to test if the problem you have is solvable with deep learning, and there we would say it makes sense to start with a small number of images, let's say 20 to 50 images per class, and do a first training with, and then see if it is feasible to solve. If this history here just is raising up and you come to a good accuracy. And then as more image you offer to the system, as better normally would your neural network get. So it's hard to say a concrete number for it. It's more to give an approach. Start with a low number of images to verify if your problem is solvable with deep learning, and then if it is solvable, start collecting images. And you can see here in the history of the training how good your training will be. In our case, with 3 classes, we come really fast to a good result. If you have more classes and more different cases, it may take longer that it comes directly to such a high result. So there are no clear number. Just start with some low numbers, and then if it's solvable, increase the number. Okay, depending on the use case for a camera and training, do you test several different deep learning architectures to find the best fit? For sure, we internally have tested different architectures, and we decided for the one which fits best for our application in this case. About all the questions which go more into the details of deep learning, I would really motivate you to have a look on the webinars we offer, especially to deep learning, because there we have a look behind the scenes. And I'm at the moment, this is what one of the next questions, what about for object detection, which nets we are using here? There, I have to say I'm not aware of. And then Robin answered the question that we are using MobileNet SSD. Okay, thanks, Robin, for this information. And can it be used as navigation device for an HEV? This totally depends on your application. At least we can classify. In the next version, we can also do object detection inside of an image. So we could then also offer X and Y coordinates of an object inside of the images. And when you have the right application for you, why not? You could also use it as a navigation device. So thanks a lot for joining this webinar. I hope you're now motivated, or I see that you're motivated to start working with IDS NXT. So please contact our sales guys. And yeah, thanks for watching. I wish you a nice day.